Hey everybody, Dave Lindbergh in Hong Kong with yet another episode of the THD Podcast. Coming up today, we have a gentleman joining us from London, a company called Chatable. Going to talk about AI, going to talk about transparency modes in TWS and perhaps how they use AI to enhance those features, and also I think some audio enhancement as well to help people with hearing health. So we're going to see if I'm full of BS. We'll get into that in a moment. But before we get too far, let's not forget about our sponsor, the ALTI, the Audio Loudspeaker Technology International. A very good organization for networking of people developing product, looking for manufacturing sources, looking for all kinds of components, software, etc., test engineers, product development engineers, everything you need to put together an audio product. It's a very good organization to join to find out who can help you. So without any more delay, let's get into it here. So Simon in Japan, how's it going today, Simon?
It's going really good. We had the first snowfall of the season a couple of days ago. So well into winter now.
All right, very good. And yeah, so Giles Tongue in London area with Chatable. Thanks for joining us today.
Thanks very much for having me along. And it's freezing here as well. So we haven't quite got the snow, but we're definitely frozen.
Okay, that's good. So yeah, like I always try to take a gander at your website and try to learn a bit about the guests before we start. And so yeah, you can basically tell me if I was making stuff up or how accurate we were with our prologue there.
Well, it's probably the other way around. You know, how good's our marketing material? So let me just fire up a little presentation here so that we can lean on that a little bit.
Sure.
Cool. So yeah, we're Chatable. We're licensing Edge AI for conversation enhancement, which is upgrading noise cancellation for consumer earbuds, or TWS earbuds, as we can probably call it in this company. So a little background to who we are. I'm standing on the shoulders of giants here, really. Our CSO, Dr. Andy Simpson, who is an expert of auditory neuroscience, deep learning, AI, and working at the intersection of neuroscience and AI, has developed the technology that we've spent the last few years taking from kind of lab scale and server scale through to where we are now, which is Edge AI. My background is from marketing and business development through to leadership. My last business was Nerve, where I was building wearable tech product. And prior to that, Tech21, which was a huge successful story and continues to be in consumer electronics. And before that, Unilever and various other consumer brands. The business was set up with an investment from Mark Cuban, who some of you will know, Texan billionaire who likes to invest in AI and other things. And we've been going since about 2018, and we have the world's first zero latency AI, or Edge AI.
Okay.
So do you want me to keep going, or do you want to jump in there?
Yeah, no, we'll interrupt when something puzzles us or we got something to add.
Cool. What's puzzled you so far?
Coming up, what's zero latency in AI?
Yeah,
maybe that's coming up shortly.
I knew you'd want to get into that, so I'll just press pause on you, Simon, and we'll come back to that one. The answer is 2.3 milliseconds, but we'll come back to that. Yeah. So we're focusing on TWS earbuds at the moment because it's the fastest growing segment probably that there's ever been in consumer electronics. According to FutureSource, 2 billion pairs of earbuds are going to be sold between 22 and 25, and they're estimating that 300 million was sold this year. So this probably is the fastest growing segment of consumer electronics we've ever seen, and maybe we'll ever see. The popularity of earbuds is extraordinary. So active noise cancellation, or ANC, has become ubiquitous because nobody likes noise. Simon, perhaps I'll bring your expertise in here to tell us what ANC is.
All right, then. So what you do is you're going to detect the external noises and use the speaker to cancel out that sound with the opposite waveform.
There we go.
Nice.
And that's become ubiquitous. I guess Bose were early pioneers there, and it's become adopted and like a table stakes feature for TWS now, simply because when you're using your TWS for your podcast, phone call, Zoom meeting, voice assistant, whatever it is, you don't really want to be interrupted by the noise around you. So ANC's become basically a table stakes of anything from mid-tier upwards. And even, you can get as low as sort of $30 products now with ANC in it. But ANC cancels everything, even people. So although we call it active noise cancellation, probably we could call it active sound cancellation, because all sound is cancelled, or that's the intention of ANC. So even people are taken out with this. So if you're wearing your earbuds and you don't really want to take them out, so like me, many people will start their commute by putting the coat on, putting the hat on, and if you're in the UK, putting your umbrella up and then putting your earbuds in. And you start with your music and your podcast, and then the phone calls start, and suddenly you're at your desk and you've got meetings going and you haven't taken them out yet. But now you want to talk to someone. So how are you going to do that? One option is transparency mode. So you switch over from noise cancellation to transparency, which is what this Apple example is here. Other people call it pass-through or hear-through mode. And then you can hear the other person, but you've also let the noise in, and then actually you've switched off the ANC that you've just spent a load of money on. So it's kind of an unsolved problem to this point, is how would I continue that conversation without also switching off my ANC and allowing all the noise in? So that's what we're doing. We're allowing ANC to selectively cancel noise, but let in conversation. So we're allowing ANC plus conversation, if you want to think of it that way. And we're calling this AI Transparency Plus, because we're adding AI to transparency to make transparency into the thing it probably wanted to be to begin with, but is incredibly hard to actually do. So this is the future of noise cancellation for TWS earbuds and other headwear. Oh, that's fun. I've just clicked on a link. Let me come back.
Now, is this something that we would have seen a little bit in hearing aids previously, where they Yeah, go ahead.
So hearing aids are really amplification devices. So they're not trying to cancel noise. They're trying to amplify sound. Specifically, they're trying to amplify the sound that you want to hear. So whether that's the sound of speech or other things, but they're typically amplification devices. And they're using amplification plus custom EQ plus compression to handle that amplification task. So whilst generally speaking, a hearing aid is a transparency tool, it fits the same kind of definition. Sound comes in, it gets passed through to the receiver and into your ear. So you could think of it as basically an early transparency device. They're not noise cancelling, so it's different in that respect.
Okay.
So conversation enhancement, according to a Future Source report, is one of the most requested features of next generation earbuds. And to them, they define conversation enhancement as the use of algorithms and DSP to amplify and enhance voice pickup in situational environments. And situational environments basically mean social environments, coffee shop, pub, restaurant, whatever. And that's exactly what we do. So we've kind of thanked Future Source kindly for coming up with that phrase, and we've run with it. So we call this conversation enhancement AI. Oh, I keep clicking on links.
And
Sorry.
so that's like helping people like focus. So like you've got this noise floor, and then you're trying to hear somebody across the table from you rather than the music in the background. So that's
right. So this is really about focus and attention and your ability to with less effort. Really, it's about listening effort. Reduce the amount of effort to listen to the person that's speaking to you. So we're bringing down the background noise, we're bringing down the room sound, and it's leaving that voice preserved, and we can even bring the voice up. So that's what we're doing here. So with transparency mode and AI, you get this conversation enhancement. So it's a new experience from Chatable, designed specifically for earbuds, can be used in other ear-worn devices.
Mm-hmm.
So by upgrading your ANC with our industry-leading AI, you're addressing some hot trends which are going around at the moment. So obviously putting AI into a device is a cool thing from a marketing perspective. And I think users will, the first people to hear with our AI will effectively be listening to AI, which is quite a cool concept. And this is a trend of ANC with transparency mode, which is table stakes of the next generation at the moment, and conversation enhancement according to Future Source, which is the most requested next generation feature. So it's hitting a lot of trends at the moment for TWS. So we are going to let conversation in and leave everything else out. So I think this is probably where you'll start to get interested when we talk about the tech specifically. So this is a proprietary AI platform. It's been designed specifically for TWS. And in fact, it's been designed specifically for the chip we're running on, which is from Knowles, which we'll go into in a second. And it's using what we call inline deep neural networks, performing 100 million calculations per second. And it's scientifically proven neuroscience-based AI with premium zero latency sound. So this is a step change in edge AI. And for anyone wondering what we mean by edge AI, you've got AI that can sit on a server, so in the cloud, AI that perhaps works on a desktop or other device. And then edge AI means it's sitting on the chip and it doesn't need anything else to run. It just runs from that chip. And in this case, it's running on a chip sitting inside an earbud. So this is now award-winning real-time AI, for which we have patents pending, which is allowing the ANC to selectively remove noise whilst providing crystal clear conversational speech with no latency. And before I move on too quickly, we have a white paper on our website. So if people want to dig more into what we're doing, then there's a white paper there. Just scroll down to the bottom of chatable.ai and you'll find sorts of interesting stuff.
We can put the link in the description below.
Oh, perfect. Yeah.
What's the significance of the 6 millisecond latency barrier?
Yeah, so I'll come to that in a second, but essentially this is about the perception of latency and the we'll talk about it in a moment. It's easier if I put up a slide to support it. This slide here, in fact. So this is the first conversation, Enhancement AI with no latency. So typically, if we talk about latency for conversation to begin with, so on a Zoom call, for example, we might have a latency which results in everyone speaking over each other. So that's a problem. But with Zoom, we kind of get used to it. If you're sitting across a table in a coffee shop with that kind of latency, it gets unusable. And in fact, at worst, it can make you feel a bit unwell when what you're seeing and what you're hearing are disconnected by an egregious level of latency. On top of that, you have the own voice problem. And the own voice problem is that you can hear yourself say something. So you sound like this, and that is just not usable. So we therefore have to get below a certain threshold of latency. So perception of echo, this kind of hearing my own voice, is about 30 milliseconds. The hearing industry want to get below 6 milliseconds. So our AI latency at the moment is 2.3 milliseconds, and then you add in whatever the system is. So if, for example, you had an AI that was running on a smartphone and was tethered to your listening device, your earbud, then you would have to add Bluetooth latency as part of that latency calculation. So the importance of being on the edge is very clear. It gets rid of that chunk of latency. The rest is then down to the operating system that you're working on, and then your own algorithmic latency. So with our algorithmic latency down at 2.3 milliseconds, we then add on whatever latency is on the system inherently running the operating system. And that gives us the total end-to-end or round-trip latency, which on our Knowles system is 7 milliseconds. So, and that is really imperceptible. I would challenge anyone to tell me that they're having any difficulty with that latency.
Yeah, I think I remember in live music trying to do wireless. Usually most people were targeting a total, on the RF side of a 5 millisecond latency for an electric guitar or something like that. And you'd have to be pretty sophisticated in your hearing to detect it. But, right. There's always musicians that claim that they could hear that difference.
Well, there's always someone. And often when testing, we get people doing the old click test to see if they, right. We're focused on conversation, and if the conversation is imperceptible, the lips are moving at the same time as what you're listening to, then you're there basically. But that is a very, very tight threshold. So the challenge, of course, with AI is AI typically has two problems. One is that it's big, and that's typically why it sits on a server. And the second is that the algorithmic calculations are also huge, which in itself adds latency. So there's a huge amount of calculations going on. And by the time you've chucked something out the other end, you've added a chunk of latency. So this challenge of reducing latency really is probably the single biggest achievement from a technological point of view that we've done. And then to do so whilst retaining a natural sound is also a huge achievement, because typically with noise reduction or conversation enhancement algorithms, you're trading off sound quality with your background noise removal. So being able to retain that natural sounding voice, and I would say our benchmark is it sounds just like the person. You know, if you can hear that it's been synthesized or you know it's come out of an AI, you know, I'd say probably you wouldn't. And then the final part, of course, is having something that's computationally efficient enough that it can sit inside a chip. So we're down at 900K for the Knowles chip. We used all the footprint that was available there. So with this tiny implementation of our AI running with zero latency, altogether, that's what makes this a technological achievement, really.
Okay, and is it exclusive to the Knowles platform? For now?
No, it's not. It happens to be that through a partnership started early in 21, we worked together with Knowles. We walked through the door of Knowles at the same time they were positioning their DSP chip, which they call the AI Sonic Chelsea, the IA8201. The same time they were positioning that for use in TWS earbuds. So as they were talking about, hey, we're going to build this development kit, which you can see on the right-hand side of my image there, we walked in and said, well, this thing is AI capable. How would you like some AI to run on your AI capable chip as a kind of demonstration? So we worked together throughout this year to develop that. And it gave us a platform really to fulfill our vision, which was an AI that could work on a chip. So it's been a really nice sort of symbiotic relationship. So from about August, we had this working. And since the travel situation has eased a bit, I've been able to go out on the road with this Knowles chip. And that's why I'm wearing this funny cap, is we have this Knowles system, which we can put on the cap. So this is basically, and I'll show you a diagram of this in a second, but this is basically everything that you need inside a TWS, with some earbuds hanging out of it. And then we just plonk that on someone's head and then they can listen to our AI. So
cool.
Pretty funky looking, but it does the job very well. So we're happy with that. I was skeptical of the hat to begin with, but it does add somewhat. So here's the image of what I've just shown you there. And you can see that that's the Qualcomm 5141. That's the SoC that basically gives you a TWS earbud. You know, add a battery to that and a few other bits and bobs, and you're off and running. This chip here, which is about 2.6 mil squared, is the Knowles Chelsea chip. So what we're finding at the moment is people who are interested in using our AI on their earbuds are designing in the Knowles DSP as an addition to their existing design. So it's giving them a very fast route to market, and Knowles is supporting with the integration side. So that's working very nicely so far as a kind of route to market there.
Okay.
So your question was, is it exclusive to Knowles? Well, it's not exclusive to Knowles. It happens to be that it's available today and ready to go on the Knowles system, but it can work on any other chip that we basically look at the resource profile from a processing point of view and a memory point of view. Processing doesn't seem to be a problem because we're pretty efficient. It's the memory that's the kind of the threshold that we sometimes jump to first. So going back to the technical bits and pieces here, this AI Sonic chip from Knowles is using the Hi-Fi 3. There are Hi-Fi 4 and Hi-Fi 5 available or becoming available. So any of those cores that are being used, we can probably run on. Round trip latency at the moment, we're about 7 milliseconds. Our AI is 2.3, and then there's another three or four. So from a processing on the OS side point of view, we're using about 900K. The AI that we're using right now for our demos is doing 100 million operations per second, which gives us about 2.5 hours of battery life on a 70 milliamp hour battery. We do have another version which is 50 million operations per second, which is twice the battery life. So if people are really concerned about battery life, we can use that. But typically, this is what we would regard as a situational or a temporary use case. So having 2.5 hours battery life on a TWS earbud that's going to be regularly recharging is not an issue. Mm-hmm. So one other point of interest possibly is that we're not using TensorFlow or TensorFlow Lite or any of these other AI platforms. This is ground up AI that we've developed ourselves. So we go all the way back to the core and get as close to the metal as we can, and then build again on C++ and walk forward from there. And this can be a floating point, fixed point, or whatever you like kind of implementation. We have all the controls around this since we've developed it from the ground up.
So the AI in this context is effectively trying to extract human voice content out of some arbitrary signal.
Yeah, you got it. Yeah, exactly.
And so you've got around you've got the neural network or some processing that you can do to extract that voice content.
That's right. Yeah. So one way I like to express that is sound goes in complex and comes out simple. Yep. So we are producing at the other side a voice, or as much as we can, a voice only system signal. When you use our AI with the companion app, we have a slider in it. So you can actually control the amount of background noise that you want to come out, because not everybody wants to sit in, silence. So you can have a bit. So you might be watching a film or talking to a friend. You don't want to be in a kind of spooky silent world. So instead you would control, how much you want in, which could be.
There's kind of a couple of layers to the technology. One is that science of how do you take a signal and get human voice out of it. Another layer is how do you actually make that practical with whatever chips are available. Is that a fair?
Yeah, totally. 100%. Yeah.
So are both of those quite unique? I don't know. Has this extracting human voice from noisy signals, is that a mature thing, or is that still?
No, it's as far as we know, that we're the only people with an implementation that's practical in an earbud solution. So there are probably examples of NVIDIA or others doing this on NVIDIA-sized GPUs, mm-hmm. And server-sized GPUs, probably for Zoom calls and such. But to do this on the edge, so it's a twofold thing really. So one is how have we done the speech and noise thing? The cocktail party, if you want to call it that. So that's one thing. The other is how have we done it with no latency on a size efficient enough to work on a chip?
Yeah, and so the is that layered on top of ANC, or is the ANC aspect just intrinsic in that processing?
So you could think of it as two parallel streams. So you've got your ANC going, and then we're over here, and then we come together, and that's what you listen to.
Yeah. So you don't necessarily need to connect it to ANC. I mean, it's standalone, a valuable thing, right?
Totally, yeah. So this would be giving you a clean voice signal. So even if you had like a non-occluding ear-worn device, say a hearing aid, for example, in some cases a non-occluding, then you would have this clean voice signal over whatever's going on around you. So that is still a very useful thing. Yeah. So it doesn't need to be tethered with ANC. It just fits that, if the role we're trying to perform is one of keeping noise out, then with ANC has a natural bedfellow.
Yep. Even non-occluding earbuds do give some sort of not distortion, but effect of the sound, so it becomes harder to hear even in that case.
Yeah, exactly. Yeah. So I think if we think about the likes of I don't want to say the Amazon thing, but Siri and others like that. These are platform guys who want you to use voice assistants, and their goal presumably is to keep the earbuds in all day. So they would be advocates of any solution that's going to encourage you to not have to take them out. Yep. I mean, it's a faff to take them out. Oh, hey, what did you say? So that's annoying already. Yep. But in a world where it's like all day content, constant use, voice assistants, etc., then this is a solution that clearly is going to help support that journey and that vision.
Right.
And can it be adjusted for like focus? Because I know that some pass-through technologies are used for like people who ride bicycles or something like that, and you want to be able to hear a car horn or something, or a fire truck.
Yeah, totally. So that's where the slider comes in handy. We have this slider for the background noise, so you don't have to have it all the way down, so you're just getting voice. You can have it up, so you've got some context around you.
Okay.
So we're effectively launching this at CES. We together with Knowles, as I mentioned, we've been working all year on this. So Knowles entered their chip here, the IA8201, which is also referred to as Chelsea, with our AI for a CES Innovation Award, which we got this honoree. So we're going together to CES to talk about that and demo that. So we're looking forward to that, and that will be like the big unveiling. And we're also getting our hands on a new system. This system here will be retired and replaced with a new one, which has got the Ole Wolf driver in it, which is going to help us with a broader spectrum of sound frequencies, and also it will have, as a result, enhanced ANC. So we're really excited about that, because those are both just sort of going to double up, probably in an exponential way, the experience that's already available on that system.
Okay.
So that's the deck. I'll just stop sharing now.
For somebody who wants to implement it, how simple is it? I mean, do you say, okay, I'll just buy the chip, solder it onto the board, and it works? Or is there a kind of a development integration process?
Yeah, so the simple answer is yes, that is basically it. On top of that, we will do improvements, which people like to call tuning, but it's a little bit nuanced for us. But yeah, there are aspects that we will look at and improve. So one company at the moment is building this into their existing design. So they're adding the DSP from Knowles onto their existing design. Then they'll send that to us. We'll then have a listen to it, do some modification, see if we can get more bang for the buck out of it, and then give it back to them, and off they go. It's probably worth pointing out at the moment our AI is a single microphone solution. So there's all sorts of clever stuff that we can do in the future when we move to sort of a multi-mic solution. So one question we get asked often is this beamforming? No, it's not. Could beamforming help? Possibly. We can try that. There's some sort of logic that says it would help. So we can do that with a multi-mic solution.
And is it sort of accent and language specific?
It's agnostic, because it's not really looking for specific words, or, it's not trying to find, oh, that person just said Peter, let's say Peter. So it's agnostic, really.
Yeah. Very excellent. Okay, and so you have your ANC earbuds. You steal off one of the microphone's audio stream and process on that, and then you get an output signal in what form? Is it to come out as an I2S that you mix back into the Bluetooth chip?
Oh, that's too deep for me, that one, Simon.
We can put the answer in a clip below after.
Yeah, right. Yeah. I'll get someone far more intelligent than I am to answer that one.
Right.
Okay. In any event, you take this output from the processing and mix that back into your audio.
That's right. Yeah. So there's
the audio music and ANC or whatever you want, and you add in this voice content essentially.
That's right. Yeah.
Spectacular.
A little bit of a mux. All right. Let's see, what else can we know? So yeah, in terms of like technical support around the world, how are you guys managing that at the moment? Besides London, where can we find you?
Well, at the moment we're confined to a small team in London.
Okay.
Hopefully, we'll be scaling soon. We're lucky that with our Knowles relationship, the tricky stuff, which is the integration work, is being handled by their much more considerable team. So far, we've not really disappeared into any sort of technical rabbit warrens. And instead, it's really been about demonstrations, and then once implemented into sort of tuning. So the support's all coming out of the UK from the core team, which I think is an advantage right now. Obviously, in time that will change, but anyone who's working with us right now get to speak to the real experts.
Okay, and then when could we expect to find a product in the shops using your technology? You say,
Well,
I think you hinted something's coming pretty soon.
Well, the good news there is that if you're going to Best Buy right now, you'll be able to buy a product called Noople. And Noople are using our second generation of AI. And they're focusing on hearing impairment and the difficulty of hearing speech and noise. So you can use that. The Edge AI, which is the 3.0, the new generation. We've only been on the road for the last since October, really. So we're just out demoing that now, and we're going through some sort of evaluation phases with a few different companies at the moment. So all being well, towards the end of 22, we should have some products in market.
Okay, and you'll be a part of the little Knowles Pavilion at CES. I'm not sure what their plan is, but
yeah, they're going for a suite type operation. So we'll be there. They've got whether it's one suite or 3 suites, but they have a demonstration space where I'll be there with identifiable with this catchy cap, or perhaps I'll be wearing the Knowles one, depending on how political I'm feeling. And I'll be there doing demos. And our demo's dead easy. We just whack the hat on. Somebody gets to play around with the app, and you have a conversation. I mean, there's a temptation always to try and take this into a lab and do lots of evaluation. The best test for this is in anger. Go to a coffee shop, go somewhere that's noisy, go somewhere that you'll realistically use this, and let's see if it helps. Is it a useful thing? Did you have to take your earbuds out this time? No, you didn't. Okay, well, that's a good start. Did it perhaps make conversation more interesting or easier? Well, that's definitely an additional benefit of this.
Sure. All right. Well, I think that's a pretty good and clear introduction to Chatable. Simon, did you have any final questions?
Oh, I think I might have covered it.
All right. Giles, anything to add before we say goodbye to the audience?
No, I want to thank Simon for being gentle with me, knowing his expertise in this space. And if you want to find more information, chatable.ai. There's our link there to the white paper, which will also be below this video, I believe. And I'm active on LinkedIn, and you can look me up there, Giles Tongue on LinkedIn. You'll see me there. And if people want demos, just get in touch, and we'll very happily come and see you wherever you might be, and experiencing it is the best way.
All right. Okay. So thanks everybody for watching. Please like, subscribe, and especially share and comment. Give us your love, give us your hate, whatever it might be. And we look forward to, this will be the first video of 2022. So we look forward to following you through the rest of this next year as things get back to normal. So take care, everybody.
Thanks, Charles.
Thanks, guys. Cheers.